Let's take a look at a practice problem together dealing with limits at infinity of a particular function together. So the function we're going to be working with here is f of x is equal to this x over the square root of x squared minus 4. Now, what's important to know about these limits at infinity is as we consider the values of x as they get larger and larger, we have to see what is going to happen with the regular numbers or the constants in the equation or the function. So if you take a look at this -4, this -4 here, as x becomes just say 100 or 1,000 or a million or a billion, that -4 really becomes less and less significant. Now, I know it's a little bit strange to just think about ignoring a number there, but if you really think about it, as x becomes infinitely large, that -4 becomes less and less significant. So what we can say is approximately, if we just think about what's happening with this function, we really have this x over the square root of this x squared, right? As x becomes larger and larger, that -4 doesn't really need to be there. Now, if you go ahead and take the square root of something that's squared, well, if you ever square something, it's always going to be positive, right? And when you take the square root of something, we're generally always talking about the principal root, which is the positive root. So we can always consider this as x over the absolute value of x. So hopefully that makes sense. You're always going to get a positive value on that denominator. And so, that being said, if you take a look at this first limit as x approaches positive infinity of f of x, we can also just kind of think about this as this more simplified function of x over the absolute value of x, right? Because it's going to behave the same way essentially, right? And so if you think about it, what if x is going to be a really, really large number over the absolute value of that same number? Well, you're just going to be able to get essentially a large number over itself, and that's just going to equal +1 here, right? That being said, if we take a look at as x approaches negative infinity, again, we kind of simplified this function as x over the absolute value of x. What if we have x being a really, really small number, like something very large that's negative? If you go ahead and take that value, like maybe say -100 over the absolute value of 100, which would be +100, negative over a positive would just be negative. Because they have the same value, it would just simplify down to just being -1. Now, while we did evaluate each of these limits as x approaches infinity and negative infinity, let's take a look at this graphically and visually so you can see what is going on here. Now, if we take a look at the original denominator here, keep in mind that when taking radicals, we're not going to want to get a number that is going to be less than 0, otherwise we're going to be dealing with complex numbers or imaginary numbers. So keep in mind here that we're going to say that x has to be either greater than or equal to 2, so that we get a positive value or 0 under that radical, or we can say that x has to be less than or equal to -2, because if you square anything that's smaller than -2 or equal to -2, you also get 4 or higher, right? Now, if you look at our factored version here, you can see that what's also interesting in the denominator is that we can't equal 0 in the denominator, otherwise we're going to divide by 0. So there's going to be some vertical asymptotes. So we know x actually can't equal -2, and x can't equal this +2 either. So we actually go ahead and modify our original restriction here and say that x actually can't be equal to 2, so we can say x has to be greater than 2, and actually x has to be less than -2, right? So initially I was just kind of looking here and just looking at the radical on its own, but then over here I'm looking at the radical, I guess on its own, but also in the context that it's in the denominator, so there's even more restrictions since we can't divide by 0. And so from this, we know that there's going to be two vertical asymptotes at x equals -2, as well as x is equal to +2. Now, as for our horizontal asymptotes, we actually know a couple of those from our limits earlier. One of them is going to be y is equal to -1, and the other one is going to be y is equal to +1. Hopefully that makes sense, because when you take a look at our limit as we approach positive infinity, that we're going to essentially get positive infinity over positive infinity here, which is going to be equal to 1, or some large value over itself. However, it's not ever actually going to be equal to 1 just because we have this -4 that's going to make it slightly off, right? Same idea here for our limit as x approaches negative infinity. You would essentially have a really small negative number over a positive version of it, so that's going to equal -1. However, that's where the asymptote is, and it's going to always be slightly off because of this -4. So it's going to get closer and closer as x becomes bigger and bigger or smaller and smaller. However, it's never going to actually equal -1 or +1. Now I'm actually going to go ahead and just throw this onto Desmos or graph this so you can see what this is going to look like. So let's go ahead and just make some more space for that. So you could totally plot some points on your own to come up with a graph, but this is what it would look like if you throw into Desmos and just get a pretty quick graph here. And so I hope these two vertical asymptotes at x equals -2 and x equals +2 are clear. and that these two horizontal asymptotes at y equals +1 and y equals -1 are also clear. And so when you really think about that limit here, again, as x approaches positive infinity, again, that's as you move to the right here forever, right? As you move towards positive infinity, notice what is the function approaching, or what are the y values approaching? You can see here the y values are slowly approaching closer and closer to that horizontal asymptote at y equals +1 here. So hopefully visually this makes a lot of sense as to why the limit of this as x approaches positive infinity is +1. Now on the other end, if we take a look as x approaches negative infinity, or as the function moves to the left forever on our number line, notice what's happening to our function. It's coming from the lower half here, but it's slowly approaching this y value of -1 here, right? It's getting closer and closer to that. So that's why the limit of this function, or where the y values are approaching as x goes towards negative infinity to the left, is going to be that y value of -1. So hopefully this makes a little bit more sense visually and kind of ties all this stuff together as well. And just for good measure, when we said x had to be bigger than 2 or x had to be smaller than -2, keep in mind that the function can't exist anywhere in here between -2 and +2. Otherwise, we're going to have an issue here because we're taking the square root of a negative number and we're dealing with just real numbers here. Alright, so hopefully you found the video helpful. If you did, please consider giving it a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing.